In this example, we're going to be matching the polynomial functions with their graphs, given a bunch of possibilities. So we can't just guess here, we actually have to explain our choice. So we need to figure out the end behavior, the zeros, the multiplicities, and then based on that, figure out which graph actually fits our function. We'll start with the degree and the leading coefficients. The degree of this function is 4. We have 3 x's in this parenthesis, since it is cubed, there's 3 of them, and then 1 x in this parenthesis, so 4 x's altogether. Degree is 4. The leading coefficient is the number in front of the first parenthesis, which is 2. So we have an even degree and a positive leading coefficient. So the ends will both point up. That's the end behavior of the function. So now we have narrowed it down to just a few graphs. So the only 3 that actually fit this particular end behavior are graphs C, E, and F. So we eliminated 50% of them. Now, to do the other 50%, you need to do the zeros. So take the original function, 2 times x minus 1 cubed times x plus 2, set it equal to 0. The 2 on the outside of the parenthesis does not have an x attached to it, so it does not affect our results. But x minus 1 equals 0, which means x equals 1. Multiplicity on this particular 0 is 3, since that parenthesis was cubed. This is an odd multiplicity, which means that at this x value, the graph is going to cross the x-axis. Now the second 0, x plus 2 equals 0, x equals -2. So multiplicity on this graph, on this 0, is 1. That's also an odd multiplicity, so at x equals -2, the graph is also going to cross the x-axis. Now let's look at C, E, and F and see which ones, or which one, just a single one, matches this setup. So we should have the graph crossing at x equals 1 and crossing at x equals -2. Part C, that doesn't even match the numbers. This is -3 and this is 3, so that's not what we have. Part E, that looks promising. So at -2, we have the graph that's crossing the x-axis, and at 1, we have the graph that's crossing the x-axis. So E is what you want. You can check the last remaining graph to make sure that it's not a better fit. But no, it's the first 0 that I'm looking at is at -3, which I do not have. Degree and the leading coefficient. So degree, on this one, the degree is 3. The leading coefficient is -1. So we have odd degree and negative leading coefficient. So the ends, the left end will go up, the right end will go down. So again, the possible graphs that we can have, A fits these and behavior, and D also fits that, and F fits that. Now let's go ahead and look at the zeros. So take the original function, minus x cubed minus 2x squared plus 8x, set it equal to 0. Then go ahead and solve it for x. So on this one, we need to factor out the greatest common factor, which for me, I'm actually going to take out -x, just to make my life a little bit easier in a minute. So if I take out -x, this -x cubed will become positive x squared, then plus 2x and minus 8 equals 0. We can continue factoring this, -x, and then 2 numbers that multiply to -8 and add to +2. That would be 4 and 2. 4 will be positive, 2 will be negative. Now I can go ahead and set all of these factors equal to 0. So negative x equals 0, which means x equals 0. Multiplicity on this one is 1. Multiplicity is odd, so at 0, the graph should cross. X minus 2 equals 0. So x equals 2. Multiplicity is also 1. So odd multiplicity at the x-axis, the graph will cross. And then x plus 4 equals 0. X equals negative 4. Multiplicity is still 1. So we have the graph crossing at negative 4 also. Let's see what graph matches these. So we're between A, D, and E. A has a 0 at negative 4, but this is not crossing the x-axis. This is touching it and bouncing like a little rubber ball. So we have a bounce at negative 4. So graph A does not work. Let's look at graph D. Okay, this is a good start. We're crossing at negative 4, crossing at 0, and crossing at 2. Graph D fits all of the criteria. Check graph F to make sure that you're not missing something, but graph F actually does not have a 0 at negative 4, so it's not going to work.